Hello and welcome to tutorial number 6 in this lecture series on syllogisms. In this tutorial, we'll deal with either or. It's a special case in syllogism problems, and though it's nothing new, it creates a lot of problems for students. You should watch this if you have seen the last 5 tutorials on syllogisms. If you haven't, then watch them first and then come back to this one. So let's take an example and understand this. That's the problem. So if you look at the answer options here, this is the typical structure of a problem that contains either or, neither nor as options. It's not that this is the only structure, but this is the most common one. The answer options A, B and E generally would not create many problems for the students, but they get confused between C and D. So we'll take a few examples based on this set of data and explore all the possible cases. Let's first make the minimum overlap Venn diagram. Look at the statements. 1. All canines are cats. So let's draw canines first and now cats. Okay. Statement 2. All felines are apes. So this is felines and that's apes. Number 3. No apes are canines. So basically canines and apes are disjoint sets. So let's draw something like this. Okay, number 4. Some dogs are apes. So let's draw dogs now. So it's a partial overlap with apes. So that's the minimum overlap Venn diagram. Let's go to the conclusions now. 1. Some dogs are not cats. Since it's a negative statement, let's try extending the Venn diagram. We can easily see here that the set of cats can be extended to include all the dogs. Something like this. It's possible that the complete set of dogs is contained within the set of cats. So this conclusion does not follow. Let's bring the figure back to its original position and look at conclusion 2 now. No canines are felines. Now it's very obvious. Canines and apes are shown to be disjoint sets, and all the felines are contained within apes. So it means that canines and felines would also be disjoint sets. So that's true, that follows. Now we can see that conclusion 1 does not follow and conclusion 2 follows. So in this case, the answer would be option B. Only conclusion 2 follows. So that's fairly simple to understand. Now what we'll do is that we'll keep this same set of data for the next few questions and just keep changing the conclusions. Let's look at this next one. So the data remains the same. Conclusion 1. All felines being dogs is a possibility. So it can be visualized very easily. Look at this. All felines can be dogs. In fact, all apes can be dogs. So it's very simple. It's true, it follows. Okay, look at conclusion 2 now. No dogs are canines. We know that canines and apes are disjoint sets and that some dogs are apes. But there is some part of dogs that's not necessarily apes. So dogs can definitely overlap with canines. It can be visualized. Look at this. So some dogs are apes is still true, but now some dogs are canines as well. So this conclusion does not follow. Dogs can be canines. So the answer in this case would be option A. Only conclusion 1 follows. Okay, let's go to the third set of conclusions now. Look at the first one. All cats being dogs is a possibility. Again, it's a simple one. We can easily visualize extending the set of dogs to contain all the cats. Something like this. So no violation of any condition anywhere and now all the cats are dogs. So it's possible. So this conclusion follows. Okay, look at conclusion 2 now. Some cats are not apes. There is no direct condition between cats and apes. We already know that canines and apes are disjoint sets. They cannot overlap. Now since all canines are cats, some cats would be canines. Now these cats cannot be apes, obviously. So basically those cats that are canines and some definitely are cannot be apes. So this statement is true. It follows. Now in this case, both the conclusions are true. Both follow. So the answer would be option E. Hope that's understood. Let's go to the next one. Conclusion 1. All dogs being canines is a possibility. We already know that canines and apes cannot overlap. They are disjoint sets and there are some dogs that have to be apes. So these dogs that are apes cannot be canines. So it means that all the dogs cannot be canines. So this conclusion is false. It does not follow. Look at number 2 now. All cats being felines is a possibility. This again is very similar. All the felines are apes, and canines and apes are disjoint sets. Since all canines are cats, those cats that are canines cannot be apes, and therefore all cats that are canines cannot be felines, since all felines are contained within apes only. So it means that this conclusion does not follow. So both 1 and 2 do not follow. So the answer in this case would be option D, if neither 1 nor 2 follows. Let's look at this next one. Conclusion 1 is some cats are apes. So this is an affirmative statement and we have got the minimum overlap diagram in front of us. We can see that cats and apes are not overlapping. So this conclusion is not necessarily true. It does not follow. Conclusion number 2. No cats are apes. Now it's a negative conclusion. So we should try exploring the possibilities. We can see here very easily that the set of cats can be extended to overlap with apes. Something like this. So it means that this conclusion 2 also does not follow. Since we can see that cats and apes can overlap without violating any condition. Now this is where it's going to be different. Though both the conclusions here do not follow, we would not mark D as the answer. The reason is that it's a special case. Look at the conclusions once more. One is some cats are apes. So if we are negating this, if we are saying that this is not true, this is false, so it means that we are implying that no cats are apes. Yes, that's the only possibility. Likewise, if we look at conclusion 2, no cats are apes, and we negate it, that is, we infer that it's not true, it means that we are saying that some cats are apes. That can be the only meaning of negating this conclusion. If no cats are apes is false, then some cats have to be apes. There is no other way. So it means basically these two conclusions are complementing each other. So if one does not follow, two follows. If two does not follow, one follows. So it's a special case. So in this case, the answer would be option C. So remember this. The format is no A are B and some A are B. No cats are apes and some cats are apes. So any such set can give you either or as the answer. The only thing that you need to remember here is that this would happen only if both the conclusions individually do not follow. If one of them does, then it becomes the answer. But if neither of them does, like in this case, then either becomes the answer. Remember this case, it's very important. Alright, let's go to the next one. Look at conclusion 1. All dogs are apes. This is an affirmative conclusion and we can answer this by looking at the minimum overlap diagram. We can see that some dogs are shown to be apes but not all the dogs are apes, which means that all the dogs are not necessarily apes. So this conclusion does not follow. Alright, conclusion 2 now. Some dogs are not apes. Now this is a negative conclusion. So we have to explore the possibilities as well. We can clearly see that this set of dogs can be put completely inside the set of apes, which will negate this conclusion. Something like this. So we do not violate any condition, but here we can see that all dogs are contained within apes. So this conclusion does not follow. Now again in this case, both the conclusions do not follow. Neither 1 nor 2, but this again is a special case, like the previous example. Look at them once more. Conclusion 1 says all dogs are apes. If we are saying that this is false, that this does not follow, it means that we are saying that some dogs are not apes. There can be no other way. If all dogs are apes is false, it means that some dogs are not apes. There's basically no other option. Likewise, if we are negating some dogs are not apes, we are saying that all dogs are apes. Again, no other option. So basically, these two statements are also complementing each other. So if one is true, two is false. If one is false, two is true. One follows, two doesn't. Two follows, one doesn't. So it's the second case for either or. So in this case as well, we will mark the answer as option C. So the generalization would be all A are B and some A are not B. So if the set is like this, be careful. The answer can be in the form of either or as well. But like the previous example, it would happen only if both the conclusions individually do not follow. If one of them follows, then it becomes the answer naturally. I hope that's understood. If you remember just these two cases, you would never get it wrong. Just follow the methodology of identifying it. Alright, let's move to our next example. This is it. So here, as you can see, the structure of the problem is slightly different. So mostly either or questions appear like that only, but this is also possible. So we'll do just one problem on this. Let's first draw the minimum overlap diagram. Statement 1. Some houses are schools. So let's draw houses and now schools. Statement 2. All schools are not bags. So let's draw bags and do something like this. You must remember that all schools are not bags is same as saying no schools are bags. Okay, statement 3. No bags are pencils. So let's draw pencils and do something like this. Alright. Statement 4. All pencils are pens. So let's draw pens surrounding pencils. So this is the final figure. This is our minimum overlap Venn diagram. Look at the conclusions now. 1. All schools being pencils is a possibility. Yes, it looks possible. Schools cannot overlap with bags, pencils cannot overlap with bags, but schools and pencils do not have a problem with each other. Look at this. So that's one of the ways in which this can be done. We don't violate any condition here. And all schools are pencils here. So that's possible. So conclusion 1 follows. Let's bring the figure back to its original position and look at conclusion 2 now. Some pencils are houses. Now that's an affirmative statement. So we can answer it directly from the figure. We can see that pencils and houses are not overlapping. So that does not follow. Simple. Conclusion 3. All pens being bags is a possibility. We can see from the figure that bags and pencils are disjoint sets. And since all the pencils are contained within pens, there will be some pens that will be pencils. Now these pens that are pencils can never be bags. That means that all pens can never be bags. There will always be some pens that are pencils that cannot be bags. Okay, so this conclusion does not follow. Conclusion 4 now. No pencils are houses. Again, this is quite simple. We can use the same figure that we used for conclusion 1. This one. So here we can see the overlap between houses and pencils. So this conclusion does not follow. So 1 follows and 2, 3 and 4 do not follow. Now you have to be very careful here. One might be tempted to mark A as the answer here. But look at conclusions 2 and 4. This is the same case that we discussed in example 5. It's a complementary pair. If some pencils are houses is negated, it means that no pencils are houses. Likewise, if no pencils are houses is negated, it means that some pencils are houses. So one of them has to be true. And we have an option like that. Look at option C. It says two things. 1 follows and either 2 or 4 also follows. So that's precisely the case. So the answer here becomes option C. So you have to be careful with either or when the question structure is like this. Just remember the two cases that we discussed and you would always get it right. So that's where we wind up today. There's nothing in syllogisms that you need to do beyond these 6 tutorials. If you haven't followed anything, just go back and watch everything again. Now it's up to you to practice and improve your speed and the accuracy. These questions can give you some quick marks in absolutely no time. Wish you all the best.